90% students lose marks in Nernst equation. After this video, you will be confident and clear about solving any Nernst equation question without any difficulty. Let us start. The first most common basic Nernst equation, which is E cell is equal to E naught cell minus 0.0591 by n, where n is equal to number of electrons involved in the reaction, and log Q, where Q is equal to reaction quotient. Q is reaction quotient here. So observe the basic reaction. This already you know. Now, if we further modify the Nernst equation, if they specify at equilibrium, think that if cell is at equilibrium, cell cannot produce any more current. So then we take here E cell is equal to 0. And then at this condition, reaction quotient becomes equilibrium constant. So if it is equilibrium constant, if we substitute the values, then we are going to get here E naught cell is equal to plus 0.0591 by number of electrons involved by into log equilibrium constant. So one more expression we got here at equilibrium condition. If they specify cell is at equilibrium, then we use this one. Okay, next. So after knowing equilibrium condition, another condition see here. If cell is concentration cell, if cell is concentration cell, what is concentration cell? See, concentration cell that is made up of same material, oxidation part as well as reduction part made up of same material. You specify if cell is concentration cell. Concentration cell is made up of same material. For example, if I take one example for better understanding, see here zinc plus 2, aqueous, solid. Even reduction part, zinc plus 2, aqueous, zinc solid. So here anode as well as cathode both are same. Anode, cathode both are same, both are made up of same material. For such cells, E naught cell is 0. As both are same, if you reverse the reaction, overall E naught cell becomes 0. Standard potential becomes 0. So overall net modified equation is, you will get like this. Modified equation, E cell is equal to minus 0.0591 by n log Q. For example, what we write here, log Q here. For this equation, log Q, how you can write? See now, equation log Q for the given above concentration cell. So you can specify like this. Q is equal to concentration of anode, because if you write net equation, zinc plus comes to right hand side, zinc plus 2 anode by zinc plus 2 cathode, zinc plus 2 cathode. So concentration of anode by concentration of cathode, so we get expression like Q. Okay, next moving to other case of Nernst equation where we use hydrogen electrode. We know standard hydrogen electrode, reference electrode. So reference electrode Nernst equation, see now. If I take reduction potential of hydrogen electrode is equal to standard reduction potential of hydrogen electrode, SRP, standard reduction potential of hydrogen electrode, minus 0.0591 by number of electrons 1 we take in this equation, log partial pressure of H2, where it is power half by H plus ion concentration. So it is one equation where hydrogen electrode as, which type it is? Hydrogen electrode as cathode type. Reduction occurs cathode, right? So hydrogen electrode now acting as cathode. So under such cases, we use this formula. ERP reduction potential. So now here you mention clearly. Here SHE, standard hydrogen electrode as cathode. If it is acting like this, then we get this equation. Partial pressure of H2 half by H plus ion concentration. Similarly, if I write in terms of anode, where oxidation potential is equal to ESOP, standard oxidation potential, minus 0.0591 by 1 log. So here what you will get? Reverse. Here you will get reverse. pH by partial pressure of H2 half. Why we are writing half? In reaction you will get half. Half H2 per 1 mole. That's why we are writing here half. See now. One more equation. If hydrogen electrode, question given as anode, SHE as anode, see here. Standard hydrogen electrode as anode. Okay. Remember here E0 SRP, E0 SRP and E0 SOP. Standard oxidation potential and standard reduction potential of SHE, standard hydrogen electrode, is assumed as 0. Because of negligible potential, they assumed it as 0. Okay. Now another case, which is most important case. Now if hydrogen electrode, like standard hydrogen electrode as concentration cell, standard hydrogen electrode as concentration cell, if I consider, like see, as concentration cell. Under this case, whenever standard hydrogen electrode used as concentration cell, now both are hydrogen electrodes. Under this case, here what you will get? Equation C. Here equation, what we need to remember, whenever hydrogen electrode used as concentration cell. So which is equal to E cell is equal to, however it is E0 cell is 0. So directly I am writing now minus 0.0591 by 1 log 10. So C1 as well as here I am writing here concentration and then P1 power half by concentration 2 and P2 it is P2 and P1 by half Q value. What is here C1, C2? Let us see here. C1, C2, those parameters, whatever we specified, C. If SHE has concentration cell, if you are using SHE as concentration cell, then how we need to consider P1, P2, respective values here given, C. You write clearly P2 power half. So where C1 is concentration of anode, concentration of H plus of anode, and then P2 is partial pressure of H2 at cathode, and then C2 is, these are important because most of the questions based on P1, P2, C1, C2. C2 is concentration of H plus ions of cathode, and followed by P1 is partial pressure of H2 at anode. Okay, these values for concentration cell. Further, if I modify one more condition, see here, one more condition. If P1 is equal to P2, if P1 is equal to P2, then reaction you can modify like this. Whenever we are writing P1 is equal to P2, reaction is E cell is equal to 0.0591 log C1 by C2. C1 by C2. So one more formula we got here. If P1 is equal to P2, this formula you can use. Purely based on condition. Right. Further, if I take concentration here, what is C1? C1 is concentration of anode. Right. Further, how we can modify H plus of anode, H plus of cathode, they mentioned, right? pH formula, how we can write? See here. pH formula. See here, next one. If you modify C1 like E0 cell, which is concentration of H plus of anode, E cell is equal to here plus 0.0591. In terms of pH, you can write question like this: pH of anode minus pH of cathode. pH of cathode. See one more formula we got here. Once if you know all cases without any difficulty, easily you can solve questions. If weak acid given, strong acid we consider pH of anode minus pH of cathode. But whenever weak acid given, how to approach the question? Weak acid is given, then you can mention like this. Overall formula here, E cell is equal to minus 0.0591 N log 10 acid dissociation constant of acid 1 and concentration of acid 1, acid dissociation constant of acid 2, concentration of another acid under root. This you studied in where? You studied in ionic equilibrium of 11th. Anode, here it is of cathode. K1, K2 acid dissociation constant of acid 1, acid 2, different acids. So one more formula we got. All cases if you remember, easily you can apply whatever case given in the question, easily you can apply it. So now with this information, let us solve now this year whatever question asked. See here, JEE Mains 2026 electrochemistry question, 23rd January shift 1 question it is. Once if you know this, if you know all these formulas, easily how we can solve the given question. See, first everyone read the question from your side. Read the question so that quickly we can easily, without any doubt, easily we can solve it. So how we need to proceed with this? See, given question. First, in question, here they specified in the given electrochemical cell Ag, AgCl, FeCl2 cell representation given, the cell potential will increase when different options given here. When cell potential increase, for this first we have to write net cell equation first. See the answer for this. Net cell equation what you can write according to given above equation. Ag is solid plus Cl minus plus Fe plus 3, Fe plus 3 later converted into Fe plus 3, right? So here it is giving AgCl solid plus Fe plus 2. It is reduction. First it is oxidation, next it is reduction. So first oxidation I wrote, then reduction. After that, using Nernst equation, using regular Nernst equation. So these are in aqueous form. It is also in aqueous form. We know only aqueous form we mentioned, not solid form in Q reaction quotient. So now E cell is equal to E naught cell minus 0.0591 by N log Q value. What is log Q here? Log Q is right hand side which is present Fe2 plus concentration by left hand side Fe plus 3 concentration and then Cl minus ion concentration. That's what we got overall based on the Nernst equation. Now you see different options. Concentration of Fe plus 2 is increased. When cell potential will increase, concentration of Fe plus 2 increased. So first case you see here, first case, if concentration of Fe plus 2 increases, if concentration of Fe plus 2 increases, what happens here? If concentration of Fe plus 2 increases, Q value increase. If Q value increase, E cell value decrease. E cell value decrease. But what they mentioned will increase when. So no doubt this statement should be false. Observe properly questions. Next, B part. Next they mention cell potential increase if Fe plus 3 is decreased. If Fe plus 3 concentration decreases, like for example, Fe plus 3 concentration decreases. Think that. If Fe plus 3 concentration decreases, what happens here? Again Q value increase, denominator decreasing means Q value increase. So E cell becomes, again E cell decreases. So again it is false statement. It is false statement. Okay. Next statement. Decrease Fe plus 2. If I decrease Fe plus 2 concentration, what happens? Q value decrease, E cell value increase. So now this particular statement is true. Statement is true. Then see remaining also. Here they specified Fe plus 3 decreases. Fe plus 3 if it increases, Q value what happens? Q value decreases, so E cell value increases. Hence statement is true. How they asked, see how many statements they gave. Then increase in Cl minus. If Cl minus concentration increases, what happens here? Q value decrease because Cl minus is denominator. So then E cell value, what happens? Increases. So even this statement also true. So now, what is correct answer here now based on this? Correct answer is CDE, correct. So here this one is correct. CDE, hence answer is CDE. CDE, correct answer for the given question. Once if you know the method, easily you can solve Nernst equation question C. JEE Main 2026, 23rd January, shift 1 question. Next. JEE Main 2026, 22nd January, shift 2. Similar to again, Nernst equation. Same Nernst equation C. How we need to solve here, Nernst equation question. Once again, everyone refer it. Refer once the question. So based on given question, if you proceed further, see here answer for the given question. I think everyone read the question. So here we know oxidation. See O2, H2, they gave standard reduction potential values they gave for both. So O2 1.23, O2 to H2, M plus 2 to M 0.994 volts. So potential of oxygen electrode, like for example, potential of oxygen electrode, if I write O2 to H2O, we can write it as E0 O2 H2O minus 0.059 into pH. See, we calculate H plus ion concentration, we convert it into pH. So in this O2 evolution, H plus gas is produced. In O2 evolution, H plus gas is produced. Reaction like this, reaction occurs like this. For your reference, I am giving reaction. H2O giving O2 plus H plus electron. This reaction happened. That's why I wrote here directly pH. Instead of writing H plus, we can write it as pH. Okay. So now, if I substitute the values, EO2 H2O is equal to 1.23 minus 0.059 pH. 0.059 pH. See, instead of writing H plus ion concentration, I wrote direct pH. Into log minus log pH minus log H plus is pH. So instead of writing minus log H plus, I wrote pH. So then another value E0 M plus 2 to M is given as 0.994 volt. Okay, it is reduction. Here it is first one oxidation part, even another reduction part. We know oxygen gas starts evolution when oxygen gas comes out when EO2 H2O is equal to EMN or M plus 2 H. If this condition mentioned achieved, then oxygen gas comes out. So this I can modify like this. Its value is 1.23. Its value is how much? 0.994. When this condition observed, then automatically oxygen gas comes out. So now what we are doing for this, I am taking here 1.23, 0.059 into pH is equal to 0.994. Overall, if we calculate pH, approximately we get here answer 4. So answer for the given question. So here answer is 4. Integer, answer is 4. See here once again. Overall formula we know, instead of writing log H plus, I wrote pH. Values I mentioned, standard M plus 2M value given. Oxygen gas starts evolution when, if this condition is achieved. So hence 1.23, 0.994, pH is 4. I hope both the questions clear to you and all cases of Nernst equation given. So once again watch it, pause the video, write those formulas once again. For more videos, follow the channel. Thank you.